Okay, so this is 7.3c, the 5.4 page, Properties of Midsegments. So let's use number 1 and go over some properties that midsegments have. Midsegment joins two midpoints of a side. So these two segments are going to be congruent since the midsegment goes between the midpoint. The midsegment is really the average of the distance of these sides. So if we had pretended there was a side here that had a 0 length, and let's say this side here is x, then 0 plus x divided by 2 is going to be the length of the midsegment. If we had a trapezoid, we're talking about the midsegment of a trapezoid, then we would have, say, x and y for those side lengths, and the midsegment length would be x plus y divided by 2. So in a triangle, one side is a 0, the other side is an x. X divided by 2 is going to be the length of the midsegment. In a quadrilateral, the midsegment joins the midpoint between two sides. Again, midpoint, those pieces are congruent. It's going to be parallel to the third side and also the average of those two sides. So let's answer some of these questions. See what we got here. So it wants us to find A. If this is a 37 and this is a 54, that comes out to be 91, which means that 180 take away 91 is going to be 89 degrees. So that's an 89 degree angle there. This is a parallel line to this one. The midsegment is parallel to the third side. So by corresponding angles, we have parallel lines cut by a transversal. A must be 89. To find the measure of B, we're talking about these parallel lines with this being the transversal. This 54 and B are also a pair of corresponding angles. So B is going to be 54 degrees. And then angle C is going to be supplementary, or it's a linear pair with 89. It's going to be 101. It's going to be 91 degrees. So we found the measures for number 1. Let's look at number 2. Again, this y length is the midsegment length. It's going to be half the distance of 0 plus 14. So this is going to be a length of 7. Midsegment goes between the midpoints of the sides, which means that these segments are congruent. If this is a 16, this is going to be a 16 over this way. Z is going to be a total of 16 plus 16, which is 32. And X is going to have to be 21. Since this half is 21, the other half has to be 21. Let's look at number 3. Here's a trapezoid, midsegment of a trapezoid. Let's see, 41 plus x divided by 2 came out to be 29. 2 times 29 is 58. 41 plus x equals 58. Take away 41, x is equal to 17. So this must have been 17. 17 plus 41, 58 divided by 2 gives 29. Now we want to find out what this length here is. This z length, I'm taking this to this length here, is going to be half the distance between here and here. So half of 13 is going to be 6.5. So z is 6.5. We found out that x was 17. And we need to find out what y is. Again, this is the midsegment, which means that these two segments are congruent. If this piece is 11, this other half has to be 11 also. Let's move on. For this one, they're telling us that x, y, and z are all midpoints. So let me mark these segments as congruent. like that. Looking at this length here, this xy length is going to be the same as PZ, or half the distance of PR. This ZX length is going to be the same as RQ, or half the distance, well, it's going to be the same as YQ, or half the distance of RQ. And this ZY length is going to be the same as PX, or XQ, or half the distance of PQ. So we can actually mark these with their appropriate congruence marks also. XY equal to this one equal to this one equal to this one. So let's look. So it says that the perimeter is 132, which means all this all the way around is 132. RQ is 55. So this part here is 55. PZ is 20, which means this other piece is 20, which means this whole length here is 40. Now this adds up to 95. If this whole length here is 132, that's going to be another 37. 95 plus 37, yeah, 37. So this whole distance is going to be 37. And then, so let's see, half of 55 is 27 and a half is going to be each one of these. And half of 37, or 18 and a half, is going to be each one of these. So let's see what they're asking us. The perimeter of XYZ, each of these added together is going to be a 20 plus a 27 and a half plus a 18 and a half added together. So we get 0, carry the 1, 8, 16, carry the 1, 2, 3, 4, 5, 6, 66. And it kind of makes sense. The perimeter of the mid-segments is going to be half the perimeter of the whole figure. P to Q is going to be 37. And Z to X, which is a 3 marked one, is going to be half of 55, which is 27 and a half. Okay, let's move up. For number 5, we've got that MN is the mid-segment. Find the coordinates of M and N, find the slopes of AB, and find the slope of MN. So what they're wanting to see is that AB is parallel to MN. That's what we're going to find by finding the slopes. And with the coordinates, they actually want us to find the midpoint of AC, which is M, and they want us to find the coordinates of the midpoint of BC, which is N. So they want us to find the midpoints, and they want us to find the slopes. So let's see what we can do. Let's go for the coordinates first. The midpoint is going to be the average of the x's and the average of the y's. So if we're using AC, the midpoint of AC, which is point M, is going to be the x's added together, 20 plus 4 divided by 2, comma, y's added together, 2 plus 10 divided by 2. That's going to be 24 divided by 2, which is 12, and 12 divided by 2, which is 6. So this is the point 12, 6. Want to do the same thing for N? So the midpoint of BC is going to be point N, which is the average of the x's, 20 plus 9 divided by 2, comma, negative 6 plus 10 divided by 2. 29 divided by 2 is 14.5, or 14 and a half, and 4 divided by 2 is going to be 2. So this is 14 and a half, comma, 2 for the coordinates of N. Now the other thing that it wants us to do is to find the slope of these two segments. So the slope is the change in y over the change in x. So we'll do that over here. So we want to find the slope of mn. So slope of mn equals the change in y. So we're going from 2 to 6, which is 4. Now this is going to be a negative slope, because we can see it drops down, over the change in x, which is 14.5 take away 12, which is 2.5. So this is going to give us a negative 8 over 5. I just doubled this to make it, get rid of the 2.5. We want to also, now the slope of AB should be exactly the same, so we want to find the slope of AB. With the same method, the change in y, negative 6 take away 2 is negative 8, and negative 9 take away 4 is 5. So we also get 8/5, negative 8/5 for the slope. So we've shown that the midsegment is parallel to the third side, and also we use the midpoint formula to find the middle point of AC and the middle point of BC, which are the endpoints of the midsegment. Let's look at number 8. We want to find the width of the lake without using a tape measure or without using a boat. So what they could do is start here and kind of go some distance out here, and then go some distance back here and make a triangle. And they could find the midpoint of those two sides. Like, so they could actually measure out to here, find the middle point, measure out to here, find the middle point, connect those two middle points together, and measure between these two middle points. This distance is going to be half the distance of the lake. So the distance across the lake is L. That's kind of like the base of this triangle, like right here. The midsegment is going to be parallel to this line that goes across the lake, and it's also going to be half the length of the lake, and it's going to go through the midpoint of each one of these sides. So if we were to lay out this triangle and take half this distance and half this distance, connect those together with a segment, that's going to be the midsegment. Whatever the length of that midsegment is, that's going to be the distance. That's going to be half the distance of the lake. So the lake width equals 2 times the distance, equals twice d, whatever this d is. So get number 7. M, N, and O are midpoints. So we got it marked as midpoints. What type of quadrilateral is A, M, N, O? Well, it's going to be a parallelogram. Because opposite sides congruent and opposite sides parallel. How do you know? Give a flowchart proof showing that ONC is congruent to MBN. The other thing we missed there is this says too. Well, we can sort of see that by, and this is also going to be congruent to that, with properties of midsegments. At some point, we're going to be able to say that this triangle ONC is congruent, O to N to C, is congruent to triangle M to B to N by side, side, side. Since each one of these lengths, since this length is congruent to this length, midsegment, midsegment, congruent segments, that's a side. This congruent to this, that's another side. This congruent to this, because of the property of midsegment, that's another side. So side, side, side is enough to show that these are going to be congruent to each other. Let's look at the last one here, number 8. Give a paragraph for flowchart proof. So let's see what we have. We can label what we have as congruent. PD, DF. So these are all congruent. And these are all congruent. And then basically, we depend on what we have. Like PG is going to be the midsegment of this big triangle. HI is going to be the midsegment of this triangle that has FG as a base. And DE is going to be the midsegment of this trapezoid that has PQ and FG as bases. So he wants to show that these are all parallel to each other. So let's see how we could do that. HI parallel. Okay, so I guess one way the proof could go sort of goes like this. Like if we kind of focus on this FG segment, we could show that PD and DF are congruent to FH and HR, since those are all congruent segments, as are RI and IG together with GE and EQ. So that would give F as the midpoint of PR and G as the midpoint of RQ, which would make FG a midsegment. And if FG is a midsegment, it's parallel to PQ. So we have FG parallel to PQ. We can argue that. Now let's look at this lower trapezoid, FGQP. If PD and EF are congruent, that makes D the middle point. If GE and EQ are congruent, that makes E the middle point. And the segment that connects those two middle points of those sides is the midsegment. And the midsegment is parallel to each one of those sides. So by doing that, we have that DE is parallel to FG and also parallel to PQ. So we've got those as parallel. So we've got DE parallel to PQ and is also parallel to FG. So far we get all of these parallel to each other. And then we use this triangle for the upper half, this RFG triangle. And if FH and HR are congruent, H is the midpoint of that side. And if RI and IG are congruent, then I is the midpoint of that side. That makes HI the midsegment of this upper triangle. By definition of midsegment, HI is parallel to PG. So basically, we're able to show that all these midsegments are parallel to each other and to the side of the big triangle, side PQ.